Assalamualaikum and good day. In this video, I will explain on how to solve tutorial chapter 1, question number 1 for electromagnetic theory subject. Okay, for question number 1, the question asks you to express vector that extends from point P to Q. So given that point P is negative 3, 4, 5. X, Y, Z. And point Q is 2, 0, negative 1. X, Y, Z. Okay, now you need to express the vector in Cartesian coordinates. So the given point in question already in Cartesian coordinates. So you just need to directly use this point. Okay, you can refer to this equation here. This equation already I explained it in previous lecture. So you just substitute the value of x to x1, y to y1, and z to z1 in this formula. So now P we assume as first point. Okay, so it is x1, x2, x1, y1, and z1, while for point Q is x2, y2, z2. So when you substitute, you will get like this: x2, 2 plus 3 ax, 0 minus 4 ay, and negative 1 minus 5 az. Okay, so you will get the answer directly: 5ax minus 4ay minus 6az. Okay, so this is for question 1a. Okay, for question 1b, you need to express the vector in cylindrical coordinates. So from part A, we already have in Cartesian coordinate. So we just need to transform from Cartesian, this vector from Cartesian to cylindrical for part B. So refer to the equation in this table. Okay, so you just need to substitute the ax, ay, az formula that depends on the appendix. Ax is cos phi ar minus sin phi av. Ay sin phi ar plus cos phi av. Az is az. Okay, and then okay, I just expand it and I rearrange this equation based on ar, av, az. So we don't have the point, we don't have the value of angle here. So we need to calculate based on the first point. This is Cartesian coordinate point. So you need to change it. The y-axis here, we know that y-axis we need to change to phi angle. Okay, so at point P, in order to get phi value, so refer to the table. The equation to get the phi value is inverse time y over x equal to inverse time 4 over negative 3. 4 over negative 3, we use the first point, which is point P. Here, point P. Okay, so you will get negative 53.13 degree. And then this phi value substitute in the equation. Okay, substitute phi value into PQ, vector PQ that we already transformed into cylindrical coordinates. Okay, now after substitute all the values of phi, you will get something like this. Okay, now solve it using your calculator. Make sure if you use degree, your calculator must change to degree, not radian. Okay, so after you solve it, you will get 5 cos negative 53.13 degree is equal to 3 minus 4 sin negative 53.13, you will get negative 3.2. Sorry, you will get 3.2. Okay, so 3 plus 3.2, you will get 6.2 AR. And the other one, you will get 1.6 AV. And the last term, you will get negative 6 AZ. So this one is for cylindrical. Okay. Now we proceed to question 1C. Okay, for question 1C, you need to find a vector in spherical coordinates. So we already have the cylindrical coordinates here, 5ax minus 4ay minus 6az. So this is in Cartesian coordinate. You just need to change it to spherical coordinate. So refer to the appendix here. Okay, from Cartesian coordinate is 5ax minus 4ay minus 6az. So ax, if you refer to the table, you will get this formula. This one is from ax. The second terms here, you will get ay. And the third terms here is az. So after, you need to substitute every value here. You have theta, you have phi. These two value, you don't have these two value, but you already calculate the phi value in part B. So in part B, you already have phi value here, negative 53.13 degree. So just substitute, we can use it again for spherical coordinates, only theta. You don't have value of theta. So, in order to find value of theta, you need to apply this equation that you get from table. Okay, so x squared plus y squared square root over z. So x squared, x and y and z, you need to take it from point P. Okay, we know that from question, point P is negative 3, 4, 5. So you just need to substitute all the value here, and then you will get theta is equal to 45 degree. Okay, so substitute theta equal to 45 degree into PQ vector here. Okay, so you will get something like this. Okay, after you substitute value of phi and theta, and then use your calculator to calculate all of these equations. Okay, don't forget, make sure after you substitute, rearrange the equation based on AR, A theta, and A phi. Rearrange back the equation and then solve it using calculator. You will get this answer. Okay. So for question 1, we have part D, which is the question asks you to show each vector has the same magnitude. We know that this question 1A, 1B, and 1C is from the same vector. Okay, so we need to verify that. We need to show that the vector has the same magnitude. Okay, so you just need to apply. Okay, the Cartesian, for Cartesian is from question 1A. The magnitude is 5 squared plus 4 squared plus 6 squared. Square root equal to 8.77. Cylindrical, 6.2 squared plus 1.6 squared plus negative 6 squared square root equal to 8.77. So maybe some of you wants to know where do we get this value. Okay, 6.2, 1.6, negative 6. So we go back to solution. Okay, solution 1B, the value of vector PQ is 6.2, 1.6, and negative 6. This value, you will put it, you will substitute it into this one to get the magnitude. And for spherical, this is the spherical magnitude for spherical. So from the solution, we get the vector for cylindrical, for spherical is 0.14, AR 8.62 A theta plus 1.6 A phi. So we need to use these three values to find the magnitude here. 0.14 squared plus 8.62 squared plus 1.6 squared. Square root, you will get 8.77. So it shows that each vector has the same magnitude because all of this vector is from the same vector from Cartesian coordinate system that extend from the same point P to Q. Okay, that's all for question 1 tutorial chapter 1. Thank you.